Hello students, welcome to Eshwari channel. Students, last class we studied what is hyperconjugation and what is alpha hydrogen atom. So in this video, when two structures are given showing hyperconjugation, which is more stable, we are going to learn in this video. So students, to find out the stability of the structure, you have to remember these 3 points. The first point is double bond should be connected to sp3 carbon. So this carbon should be sp3. Next is carbocation should be connected to sp3 carbon. sp3 carbon, or carbon free radical should be connected to sp3 carbon. So any one condition should be satisfied. Suppose a structure is given in which double bond is there. You have to check whether the double bond is connected to sp3 carbon, or if it is a cation, it should be connected to sp3 carbon. If it is free radical, it should be connected to sp3 carbon. So this is the first condition we need to check. Second condition is it should be having alpha hydrogen atom. So alpha hydrogen atom should be there. Only then it will show hyperconjugation. Third is more the number of alpha hydrogen atom. That is, when the number of alpha hydrogen atom is increasing, then stability also will increase. Stability will increase by hyperconjugation. So this is the point we have to remember here. When the number of alpha hydrogen atom in a given structure is more, then the stability will be high by hyperconjugation. So students, in the last class I have taught how to find the number of hydrogen atom and what is alpha hydrogen atom as well. So if you have not watched that video, so I'll just tell you what is that. See, suppose a structure is given like this. C, H, 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 and then here CH2 positive sign. So this is the structure given to you. So students, this is carbocation. So the adjacent carbon atom to the carbocation, this is called, this is the carbon which should be sp3 hybridized. So you know how to check hybridization. That is, if carbon atom has 4 sigma bond, it will be sp3 hybridized. So this carbon atom is showing sp3 hybridization. Next is, what is alpha hydrogen atom is? Suppose the hydrogen atom which is connected to sp3 carbon, we call them as alpha hydrogen atom. So this is called as alpha hydrogen atom. This is alpha hydrogen. So this is alpha hydrogen. So totally there are 3 alpha hydrogens connected to sp3 carbon. So now we'll take carbocation and we'll find stability in carbocation. So first we will take tertiary carbocation. So carbon positive sign. So to this CH3, CH3 and CH3. So 3 methyl groups are attached. So this will be tertiary carbocation. If carbocation is attached with 3 carbon, it is tertiary carbocation. We will take secondary carbocation. So secondary carbocation means it should be attached with 2 carbon. So 1 and 2. Other one will be hydrogen atom. So this will be secondary carbocation. Next we will take primary. So primary carbocation means it will be attached with only 1 methyl group or only 1 carbon. Remaining will be hydrogen. So this is primary carbocation. So students, now we have to check which is more stable. Tertiary is stable, secondary is stable, or primary carbocation is stable. For that, what we need to check is, we have to first check sp3 carbon is attached to carbocation. So see, this is carbocation. To this is the sp3 carbon attached, and second sp3 carbon, and this is one more. Here this is sp3 carbon, this is sp3 carbon, and here this is sp3 carbon. See how many alpha hydrogen atoms are there. So the hydrogen which is attached to sp3 carbon is called as alpha hydrogen atom. So 3 plus 3 6, 6 plus 3 9. So there are 9 alpha hydrogen atom in tertiary carbocation. Here 3 plus 3 6. So here there are 6 alpha hydrogen, and here 3. So what we have studied, more the number of alpha hydrogen atom, more will be the stability by hyperconjugation. So see here the number 9, 6, 3. So highest is this one. Therefore tertiary carbocation will be more stable compared to secondary, compared to primary. So you will write tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. So next we will go for free radical. We will check in free radical which is more stable. So free radical. So we will take tertiary free radical. Carbon free radical means one single electron and 3 methyl groups. 1, 2, 3. So this is tertiary carbon free radical. Secondary, so you should connect with 2 methyl groups, 1 and 2. Third one should be hydrogen. So this is secondary. So next is carbon with 1 electron and only 1 methyl group. So remaining will be hydrogen. And this is primary. So how to find which is more stable among these three structures? Count the number of alpha hydrogen atom. Where the alpha hydrogen is more, that structure will be more stable. So here you can see 3 plus 3 6, 6 plus 3 9. So there are 9 alpha hydrogen atoms here. So there are 9 alpha hydrogen. Here 3 plus 3 6, and here 3. So there are 3 alpha hydrogen atoms. So this is 9 is the highest. So tertiary free radical will be more stable than secondary. Secondary is more stable than primary. So in free radical also you can write tertiary carbon free radical is more stable than secondary, which is more stable than primary. So this is about stability. So students, see here, for carbocation also it is the same. For carbocation, tertiary is more stable than secondary, which is more stable than primary. So keep this in mind. We will take some more examples and we will find the stability. So this is the first example now. So first example, structure 1 and this is structure 2. Same way, this is structure 1 and structure 2. 1, 2, and this is 1 and this is 2. 1, 2, this is 1 and this is 2. So students, two structures are given. So you have to find which is more stable. Between 1 and 2, you have to find which is more stable. So students, see here, this is carbocation. So what we have just now learned, tertiary carbocation is more stable than secondary, which is more stable than primary. So here, check whether it is primary, secondary or tertiary. So carbocation, this is connected to 1 carbon, 2 carbon. So 2 carbon atoms means this is secondary carbocation. Secondary carbocation. Here this carbocation is connected to 1, 2, 3. Tertiary carbocation. So which is more stable now? Secondary carbocation or primary carbocation? Secondary or tertiary? It is tertiary. So this is more stable. That is, structure 2 is more stable than structure 1. So same way here you check. So this is carbocation. It is connected to 1, 2, 3. 3 carbon atoms. Therefore this will be tertiary. So this is tertiary carbocation. And here 1, 2, 3. Even this is tertiary carbocation. So students, when both are tertiary carbocation, count the number of alpha hydrogen atom in those structures. So here 3 alpha hydrogen atoms, 3 alpha hydrogen, and here 2, because already 2 bonds are there, so 2 hydrogen atoms will be there. 3 plus 3 6, 6 plus 2 it will be 8. So here 8 alpha hydrogen atoms are present. Here 3 plus 3 6, 6 plus 3 9. So there are 9 hydrogen atoms, alpha hydrogen atoms. So where the number of alpha hydrogen is more, that will be more stable. So here 8, here 9. So this will be more stable. So structure 2 will be more stable than structure 1. So students, here third example, I want you to try and write in the comment section whether structure 1 is more stable or structure 2 is more stable. We'll go for fourth example. So there is double bond. So to this double bond, you can see this carbon is attached. So to this carbon, how many alpha hydrogen atoms will be there? 3. So there will be 3 alpha hydrogens. Here 2 double bond, 1, 2. So 2 sp3 carbons are attached. So this carbon will have 3 alpha hydrogen, this carbon will have 3 alpha hydrogen. 3 plus 3 it will be 6. So 6 alpha hydrogen atoms are present. Which is more stable? More alpha hydrogen atom, therefore 2 will be more stable. So here we can write structure 2 is more stable than structure 1. So next here we can see double bond. To this double bond, this is sp3 carbon, and here this is sp3 carbon. So 3 hydrogens here and 2 hydrogen here, totally 5 alpha hydrogen atoms. Here this is the double bond and this is sp3 carbon. So it has 2 alpha hydrogen atoms. So which is more stable now? More the number of alpha hydrogen atoms, stability will be more here. So structure 1 will be more stable than structure 2. So next is last example. So here this is the double bond. So this is sp3 carbon, and this side this is sp3 carbon and this is sp3 carbon. So 3 alpha hydrogen atom, and here 2, 3 plus 2 5, 5 plus 2 7. So 7 alpha hydrogen atoms. Here this is double bond and this is sp3 carbon. So here 2 alpha hydrogen atom and here 2 alpha hydrogen atom, total 4. So which is more stable? More the number of alpha hydrogen atom, it will be stable. So 1 is stable compared to 2. So you will write here structure 1 is more stable than structure 2. So this is how we find stability in the structures showing hyperconjugation. So I'll meet you in the next video, students. Bye.